video is about linear and nonlinear. So you should be able to determine which side is linear and which side is nonlinear based on the image itself. And if you look up here, the word linear has the word line in it. So that helps you to know we're looking for a straight line. And you should see easily that this side represents a linear function. On your graphic organizer, we have 4 sections. Go ahead and label those sections. The first section we're going to look at is the middle, and that's determining what our definition of a linear function is going to be. It's a set of points with a constant rate of change, which we've already talked about, and it will create a straight line. In the table section, I've already given you the table, and because we're looking for a constant rate of change, we're going to do just what we did on the last assignment. We're going to find the difference between the numbers and start with our y over x. We should determine that you would subtract 2 every time. And then in the y's, you're adding 6 every time. So then we can substitute those numbers into our y over x, and that will give us -3. Because we have a constant rate of change, we can determine that this is linear. So here's your sentence you'll write. Linear, the constant rate of change is -3. For the graph section, please write down the order pairs that we have given you and plot them on the graph. When you plot the points, we would go -2 up 3, -1 up 1, 0 down 1, and 1 -3. And because we're talking about linear functions, this of course is going to be linear and create a straight line. Now what you've learned about finding the constant rate of change on a graph is that you're going to make right triangles or steps. Go ahead and make your steps. And we can say that it is y over x again. Our y number is always going to be whichever one goes up or down. And this goes up 2, up 2, up 2, because it's a constant rate of change. And over 1 each time. Because it is going downhill, one of those numbers needs to be negative. It does not matter which one is negative at this point, or ever at all. Just one of them has to be negative because it's going to end up being a negative constant rate of change. So because we have a constant rate of change, we can give our answer in sentence form. For the map section, we're going to use the exact same order pairs that we did for the graph. So go ahead and make connections between the x values and the y values using those order pairs. And when you do that, your lines should look like this. The first thing you're going to need to do when you're given a map is to make a table. So let's make a table where we're filling in the x and y coordinates from this map. You should get these numbers on your table, and then just as we've been doing, we are going to find the constant rate of change using our y over x. The x values are increasing by 1 each time. The y values are decreasing by 2, so you'll see the negative part of it coming into this part of it. So we would have -2 over 1, and that equals -2. So because we have a constant rate of change, we can write our sentence or our answer. The last section is the equation. For the equation, go ahead and write this one, f of x equals 2x minus 2. And to figure out if it is linear or not, for you, at this point, you just need to make a table that I've already put on the graphic organizer for you. You'll put the x, or the equation, in the middle, and we're going to pick some basic numbers because we want to make sure that they go on the graph. So we're going to pick -1, 0, 1, 2 as our x values. Go ahead and solve these so that you can get the y values and we can graph them. After you create your table, you would substitute the x values in. -1 times 2 is -2. Bring down the -2. That would be -4. 0 times 2 is 0. -2 is -2. 1 times 2 is 2. -2, which is 0. And then 2 times 2 is 4. -2, which is 2. Then you can take these numbers and plot them on a graph. So I have -1, -4, -1, -4, 0, -2, 0, -2, 1, 0, 1, 0. I can see that it's going in a straight line, so I know I'm doing it correctly. 2, 2, 2, 2. And I can connect them. Hopefully yours looks better than mine. Then you would build the stairs. That's how we get the constant rate of change on the graph. And this one's going uphill, so it's going to be positive. And it's going up 2 over 1, up 2 over 1, up 2 over 1. So we have our y over x, which is 2 over 1, which is 2. So we have a constant rate of change, so there is our sentence. But now we need to know, what do we do if we have a nonlinear function where we don't have a constant rate of change? So I want you to write this at the bottom of your graphic organizer. Just write nonlinear with a question mark at the very, very bottom. Write nonlinear with a question mark. And if you have a problem where it is not going to be linear because it does not have a constant rate of change, here is the sentence that you will write. Nonlinear, not a constant rate of change.